Welcome to Sequences and Series Part 5 Summary. We will be summarizing everything from parts 1, 2, 3 and 4. I really suggest you watch parts 1, 2, 3 and 4 before today's lesson, because today we're going to be summarizing everything from those 4 lessons. In fact, today it's not so much about doing the formulas, it's about deciding which formula to use. In fact, I'm going to rush through the arithmetic because it's really about choosing which formula to use. And today's lesson is going to be sent to both my YouTubes, Variety and Fun Math and Martin Tutorials. But as I said, I really suggest you go through all parts 1, 2, 3 and 4 before today. And there's a visual of all the formulas we've learned. Hopefully I can fit it into the camera, but we're going to go through them all now. What I've done, I've set up some questions, and we're going to use the questions to decide which formula. This is question A. 5 plus 7 plus 9 plus 11 plus 13 ... What is the 11th term? So today is about learning which formula to use. Okay, I always ask myself 2 questions. Number 1, is this arithmetic or geometric? And number 2, what are they asking us? I'm going to give you a few seconds to decide if it's arithmetic or geometric, and also to think about what the question is. Okay, I say it's arithmetic because each term's going up by 2, and the question is, what is the 11th term? It's not what do the 11 terms add up to. So I want the formula for an arithmetic for finding the nth term. That's the formula here, where A is 5 and D is 2 and N is 11. They want the 11th term, so I plug those numbers in. I do the arithmetic, it simplifies to 25. Question B. Here's a set of numbers, and again, to answer, what are the 2 questions I ask myself? What is given and what do they want? First thing, is that arithmetic or geometric? I say it's geometric. Each term we're timesing by a half. And the other question is, what are they asking us? It says, what do the first 8 terms add up to? So I want a formula for adding up the terms, not what is the term, for geometric. And that's the formula. So given that A is 80, R is a half, and in this case N is 8 because they said 8 terms, I plug those numbers in to that formula and I get 3 answers, or rather it's 3 ways of saying the same thing. Obviously, if you're doing a course, you do it the way your instructor wants. So one example is 159.375. All right, so let's get on to question C. So today's reminder to this lesson is about deciding which formula. 4 plus 11 plus 18 plus 25. And the question is, what do the first 10 terms add up to? First thing, what I say to myself, arithmetic or geometric? I say it's arithmetic because each term goes up by 7. What are they asking? What do the terms add up to? Not what is the 10th term, but what do they add to? So I want the formula for an arithmetic for adding up the terms. And that's the formula which we had before. And so I'm going to plug in for A is 4 and D is 7. And they say the first 10 terms, so I plug in for N equals 10. We simplify that, let's say with a calculator, and we get 355. Now let's do question D. All right, let's D1. We're given a series. What is the 9th term? First thing, I ask myself, arithmetic or geometric? I say it's geometric because we're timesing by a third. The other question is, what are they asking us? What is the 9th term? Not what do they add up to, but what is it? So I use the formula for finding the nth term for geometric. That's the formula which we learned. And I plug in for A is 486, R is a third, and N equals 9. 486 times a third to 9 minus 1. When I simplify, I get 0.074 reoccurring, or 2 over 27. That's two different ways of saying the same thing. Next question, what do the first 9 terms add up to? We agreed it's geometric, and now they're asking what they add up to. So now I'm going to find the formula for adding up the terms of a geometric, and I'm going to plug in where A equals 1, R is a third, and N equals 9, because there's 9 terms. That's the formula. And now we plug in for A equals 486, R is a third, N equals 9. And here again, there's a few answers that all mean the same thing. You do the way your instructor wants. So one correct answer is 728 and 26 over 27. And D3, what do infinite terms add up to? Remember, that's the formula. I made a big fuss in part 4 how simple it is, provided minus 1 is between R and 1. R is between minus 1 and 1. It certainly is. R is a third. It's A over 1 minus R. In this case, it's 486 over 1 minus a third. There it is. And that simplifies to 729. I love that formula because it's so simple. And now we get to part E. 1 plus 3 plus 9 plus 27. What is the 9th term? Do you remember the two questions we ask ourselves? Is it arithmetic or geometric? And what are they asking us? I'll give you a few seconds to think about it. To me, it's clearly geometric because each term times in by 3. What is the 9th term? So it's going to be the formula for geometric for calculating the 9th term. Not what they add up to, but what is that term. That's the formula we're going to use where A equals 1, R is a third, and N is 9. We're going to plug in there. That's 1 times 3 to the 9 minus 1. That simplifies to 3 to the 8, which is 6,561. That's the answer. Now, there's also an E2. What do the first 9 terms add up to? That's geometric. We use a formula for adding up the terms. That's the formula. We plug in for A equals 1, R equals 3, and N equals 9. So we plug those numbers in, and we simplify. And what does that give us? 9,841. And E3, what do infinite terms add to? If I'm impulsive, I'm going to use this formula, but wait a minute. R is equal to 3. It will just get bigger and bigger and bigger. This formula is only true if minus 1 is less than R and is less than 1. Here R is 3. That formula doesn't work. I wrote S infinity equals question mark, question mark, question mark. So E3 cannot be done. Or you can argue it's infinity. It's infinitely big. So I hope you enjoyed today's lesson. Today was summarizing everything we learned and about deciding which formula to use. Hope you enjoyed it, and talk to you all soon.